network. So let me introduce myself. Hello, my name is Pranjal Verma and I work at Capricorn Technology as an accounts company, and I work here as a solution specialist for water and wastewater. So before going into the session, allow me to introduce our organization. So Capricorn is India leading design and construction management technology, which is a solution provider for architecture, engineering and construction. And we are one of the Bentley partner and authorized training center. So like we have more than 300 dedicated team members, and Capricorn serve over 20,000 clients in the AC and related industries. Capricorn also has contributed significantly to the country's adoption of computer-aided design for more than 3 decades, and we offer the best solution, approaches, and practices to increase your productivity and how we can lower your project risk. And now we are delighted to inform you that we have a global footprint to serve you with our best of our abilities, and Capricorn Tech is now a part of the Arcans group. So this would be today agenda for today webinar. Like first we will go with the introduction and sewerage design workflow. Followed by we'll see how SewerGEM would be help in master planning. Then how we are going to build the model geometry. And let's suppose if you want to automate your design within the SewerGEM, how we can do that with the help of SewerGEM Connect Edition. And once we reach at a particular stage of the project and we want to see the result or report, how we can do that as well. So we have different offering within the OpenFlow product overview. So let's talk about the entire green family is for the Sewer network. So SewerGEM is one of the software which include the SewerStorm, SewerCat, StormCat, PondPack, and Culvert Master, and also the Flow Master. So it is the parent of all these particular software. That mean individually also Bentley is supporting all these software, but SewerGEM is the one-stop solution in which you can go for the like drainage design, you can go for the sanitary design part also, also the club part, which is the combined network where drainage and sanitary go hand in hand, like which is not very common in India. And as if now, but yes, SewerGEM is capable enough to help you design those type of network as well. Then on the right hand side, we have the blue family, which represent the product related to the water supply project. So if we are having the water gem for that area, let's suppose if we are having the project like under the Amrut 2.0 or JJM scheme, Jal Jeevan Mission scheme, then we follow the water gem. And initially there was the water cat, now it's follow the water gem. And also if we are going to perform the surge analysis, or if we are looking for the transient type of thing within the water supply network, for that we have the water hammer product. So this is the entire Bentley OpenFlow's family. But since today we will be focusing on only SewerGEM, so we will see how SewerGEM could help for our sewer master planning. So if we talk about the wastewater analysis and design software, which is named as an SewerGEM Connect Edition. So actually, if we talk about the GEMS, it's itself showing that is a geospatial engineering modeling system. That means if we are working on any platform, being an hydraulic designer, either we are working on a CAD file platform or shapefile platform or any independent platform, doesn't mean. By all there is a combination which give us to work at a common page. There has to be a workflow that we have to follow to reach that stage, and that could be helped with the SewerGEM Connect Edition. So SewerGEM is not just a tool for hydraulic and hydrologic modeling, it is an integrated platform that support the entire life cycle of sewer network management from initial design through to the operation. So today's webinar will cover how SewerGEM provide a basic holistic approach to tackling the complex challenges associated with the sewer system only. Later on, we will also in upcoming webinar we will also discuss about the storm part. But today we are only focusing of the sewer network. So OpenFlow SewerGEM enable us to produce optimal urban sewer planning and overflow remediation analysis design in easy to use environment. So with the help of SewerGEM, we can design and operate sanitary or combined sewer system by using built-in hydraulic and hydrology capability with variety of wet weather calibration method. So as I told about the some of the capability we have within the software. So let's talk about the first capability. We have the access single shared project data source, We can collaborate without surrendering individual cell, maintaining a data set without restriction, and model within the window ArcGIS or AutoCAD or OpenRoad, etc. Then understand result the more easily. You can spot the bottlenecks and potential surcharging with graphs and profile. Also, using the color coding element, symbology, and annotation to visualize input and result. Then easily model with scenarios. With this, we can actually configure the evaluate, visualize, and compare an unlimited number of scenarios within a single file. Then we can leverage the existing data as well. So let's suppose you can use your CAD drawing or GIS file or swim SCADA data to just jumpstart the model building process. Then we can input and save unlimited flow pattern. Model flow changes over the course of days. So we can load the model with wet weather runoff flow from precipitation using built-in rainfall distribution, or we can also go for the user-defined rainfall event. And also we can actually create a multiple storm data as well. So like software also have the other capabilities as like interoperability or sanitary load allocation and estimation. So if I talk about the interoperability, what are the major platform that we have within the SewerGEM? So there is another advantage of this software. It has the interoperability with 4 platform. So with the price of one, we can actually have 4 platform to perform the analysis. The first, if we talk about the standalone editor, is the workspace that contain the various managers, ribbons, along with the drawing pane that make up the Bentley SewerGEM Connect interface. Then we have the microstation mode. It lets you to create and model your network directly within your primary drafting environment and give you access to all microstation drafting. Then we have the ArcGIS as well. So ArcGIS is generally if we are working with any GIS platform. So for that we have ArcGIS. It just let you to create and model your network directly in ArcMap. So each mode provide access to different functionality. So certain capability they are available within the ArcGIS mode that may not be available when working in Bentley SewerGEM Connect standalone editor. Then we have the AutoCAD as well. So AutoCAD model like let you create the model your network directly within your primary drafting environment. So this give you the access to all of the AutoCAD drafting and presentation tools while still enabling you to perform Bentley SewerGEM Connect modeling tasks like editing, solving, and data management. So this relationship between Bentley SewerGEM Connect Edition and AutoCAD enables the extremely detailed and accurate mapping of model feature and provide the full array of output and presentation features available in AutoCAD. So these are the 4 major platforms where we can actually integrate our data within the SewerGEM Connect Edition. We also have other platform. Let's suppose if we have the Excel format, we can integrate that data as well within the SewerGEM. There shouldn't be a challenge. So let's suppose talk about the Sewer collection system design workflow. So the first thing that come is the planning stage. So like where we used to do the study of the location, basically like getting the past, present, and future aspect of the land, and then we switch to design the option how that particular area on the basis of study we can design the network. Then also it is important to find out the population data for that particular area so that we can make the assumption of household discharge, also the rainfall infiltration. Then after completing the planning stage, obviously we need the data to be integrated within the project. We require some data that could model within the SewerGEM. So within the product, and that data is basically come under the survey method. So here are some different survey method to incorporate that data. Like we have the planimetric survey, drone technology, and if we talk about the contour on terrain, so we have the to get the contour and terrain on the basis of which we can actually track the elevation. So that is also required. After getting the data, what we do is we build the model. So once we have all the data that could easily be integrated within the product, after doing that, what we do and build the model, then we generally perform the hydraulic analysis, or if required, we can design as well under once under once we react at a particular stage of the project. Then we can finally actually give the project delivery. And then one may question arise that, okay, we can do the planning stage, we can do the survey method, but rest the work here that I shown you, model building, or hydraulic analysis and design and project delivery, where we can do these all these things. So the answer is within the SewerGEM, we can do this. That is why in SewerGEM is very much important for sewer networking modeling. Now, on the basis of this workflow, or on the basis of like these are the sewer collection system workflow, what are the application that are present within the SewerGEM? How SewerGEM could help to follow that workflow that generally we use during the project area. So the first thing is the model building, as I discussed before. So creating the sewer network, you have the data. So you must be having the data in the CAD format, or you have the XF format, or in the format of microstation. You can integrate that data with the help of model builder or multi-source model creation tool within the SewerGEM. Let's suppose you are having the data in the form of databases or spreadsheet like Oracle or SQL, or you are having the data in the format of Excel. So we can actually integrate that data as well with the help of model building toolbar. And also if you are having the GIS data, because most of the hydraulic and hydrologic data like performing the modeling are based on the hydraulic on are based on the GIS platform. So if you are having the data in the form of GIS, we can do that as well. So all of these data can integrate within the SewerGEM with the help of model builder toolbar. And if we talk about the elevation extraction, if you are having the like 4 or 5 junction, like 4 or 5 manhole or 10 manhole, you can give the value manually. That shouldn't be a challenge. But what in case of large project? For that, we need require something that easily could be happen. So with the help of T-Rex tool within the SewerGEM, we can import the elevation. After building the model within the SewerGEM, we come to the hydraulic analysis and design. So we obviously, if you are having the background data, you will just overlay the data and you will lay out the element. We will later see on the SewerGEM, like what are the hydraulic element are there within the SewerGEM. So we just go through the layout, the element. Then it is very important for you guys, like which solver you are using. Gradually varied for if you are going for the GVF convex, or for peak flow if you are going for GVF rational, or implicit solver. Dynamic if you want to use the dynamic solver, like for if you are going for the combined sewer and sanitary as well. Sorry, sewer and storm as well. You can go for the implicit solver. And then if you are working with the any swim database, we can select the solver as an swim also. So it is very important, like the which solver you are going to select within the SewerGEM Connect edition. After lay out the element, there is the concept scenario management. So with the help of scenario management, you can actually create a multiple what if situation. Let's suppose you have to model your network for future purpose. You are modeling your network for 2040 or 2050. So n number of scenario would be required within the model. If you are going to change it within the one scenario, your data would be lost. So for that purpose, we have the scenario management concept also within the SewerGEM. Then if required, you want to design your network, we can actually design also our network. Let's suppose uh, you want to give the minimum or maximum slope value related to your pipe, or you want to give the velocity minimum or maximum. We can actually design that network as well within the SewerGEM. After that, once doing all the thing, once we reach at a particular stage of the project, and we reach to the project delivery, and we want to give the result to the contractor or anyone. So with the help of color coding and annotation, we can see the result. Or let's suppose you want to see the result in the form of contours, or we see how much velocity is coming, how much flow is coming within the pipe. With the help of flex table, we can generate the result. Then it come the engineering profile. So under the engineering profile, we can generate the profile. Or you want to see, or you want to spot the bottleneck, we can actually set the graph as well and customize your report as well. So these are the workflow application of SewerGEM that could happen within the SewerGEM Connect edition. So there is certain workflow that has to be followed. So with the help of SewerGEM Connect edition, we will follow this workflow. So let's just switch to the software and I'll showcase you like how it could be done. Okay. So, uh, once you go with the SewerGEM Connect edition, or you are having the SewerGEM Connect edition with you, so the interface for the SewerGEM something look like this. So we have the different offering over here. If we talk about the file, within the file, we can actually, save the file, or we can give the information like who is the engineer working on this file, or who is the company working on this file, or wherever you want to save, you can save it. Then under the layout, you can see all the hydraulic element related to your sewer network, or we can say related to your storm network are present over here. So like under the link section, all the hydraulic element is categorized in such a way that you can easily identify by their naming. Like you can see within the link section, it representing the conduit. Or you want to create the channel or gutter, we can go under the link section. Then there are the node section. Entirely node section represent different methodology. Like you want to create the manholes, or you want to create the catch basin or head wall or outfall. So under the node section, we can create that as well. Then we follow the runoff and pond. If you are working with the stormwater network and you want to going for the pond modeling, we can generate that as well. Then if your network work under the pressure network, so for that we have a different section. So and for that we have the pressure pipe, pressure junction, we have the pump and wet valve also within the hydraulic element within this layout tool. Then under the analysis, once we reach at a particular stage of the project, you can see that we can actually, compute our result, or we can actually, validate our result to see if my result is good to go or not. Then we have the alternative and scenario concept that we have just discussed during the presentation. Like what are the scenarios, or what are the different alternative, and what are the different what if situation that we can create within the SewerGEM. So with the help of alternative and scenario management, we can do that. Then we have the 2D modeling here. So this is the entirely new feature within the SewerGEM Connect edition. So let's suppose you are having the digital terrain model or DTM model, and you apply some of the rainfall area to that particular area. So on the basis of that, what software does is it will just simulate your result, and it will showcase you like which is the area where water is getting more accumulated. So on the basis of that, what you can do is you can actually identify the risk prone area, and you can plan it accordingly. Okay, that would be my particular area. We need to invest on that area. On the basis of where water is getting more accumulated, we are going to plan accordingly. Then we have the component, like in previous webinar that I have given within for the water gem. Under that, within the component, we have the demand allocation. And within the Siva gem, what we have the storm data. Let's suppose you are going to input your storm data. We can do that. Then we come the loading process. We have to actually, give the sanitary load if we are talking about the Siva network. Then also pump definition or pattern for 24/7. Then we can view the result in different format. We can view the result in graph format or profile or flex table. Then under the tool, we can actually, here you can see as I showcase you previously. So we have the model builder tool. With the help of model builder, we can actually, integrate the data of different format. Let's suppose I'll showcase you like what are the format that we can actually, integrate. So here you can see under the data source type, we have the SD shape file. Then we also have the CAD file, or we are also having the Excel data source type. So we can just select that data source type, and we can integrate that model within the SewerGEM easily. Then we have the T-Rex, which is generally for the terrain extractor, or we can say the elevation extractor. And also we have the load builder concept over here. So with the help of load builder, we can automatically assign the load for all the manhole. And here then, once you compute your result and you want to see the report, or you want to send the report to anyone, we can generate the report. So generally the report is required for the conduit or manhole, or if you're having the catchment, if you're working with the stormwater network. SewerGEM not only work for the sewer network, but also it work for the stormwater as well. Do remember one this thing. So let's suppose this is your network. You built your network within the SewerGEM. And if I talk about, we have the manhole, we have the conduit. So, and the flow of direction indicating, okay, my flow is going to particular that outfall. So if I discuss about the first thing, what are the mandatory input, or what are the like input that we have to give for a particular hydraulic element. So in case of outfall, if you go to the property section, you can see what we can do is we can generally just give the boundary condition for the outfall. So here once I go and check what are the boundary condition are present within the SewerGEM. So you can see. So for the outfall, we have the boundary element or crown or free, or it is your free outfall or normal outfall. You can just select that according to the nature of the project. We can select that boundary condition. After doing that, let's suppose if we have to give the value for the manhole, like today we are talking about the sewer networking. So on that basis, we have to actually apply the dry weather load. So once we go for the loading option here, so here you can see once we click on the drop down menu, we have the unit sanitary dry weather loads. So once we go for the dry weather loads, so here, if you want to give your data, you can actually just go and give your data. So we have the different of method over the SewerGEM. Like we can give the data on the basis of area based if you are having the data on the basis of area based, or if you are having the data, let's suppose I select the area based. So here you can actually set the area unit or how much unit load is there, which is gallon per day for per person. So let's suppose you are going to give the data on the basis of count based, then you have to give the input for the count load unit. So similarly, it is totally depend on the choice of the project, like what data you are having. Data is much required to integrate that within the SewerGEM, or you want to give the data if you are having the data in the format of discharge based or population based. So you can give that. Not if there, if you are not having the data, there are some of the library that is inbuilt within the SewerGEM. So some of the standard has been already set up within the SewerGEM. So if I go and you can import that library, as you can see, once I open the inbuilt library, here we have the different offering for the libraries. Let's suppose you are having the airport near your network, or apartment, or coffee shop, or office. If I select the apartment, here you can see the standard unit load has been given already, which is 68.80 gallon per day. If you want, if we wish to give the value from the library, we can give that as well. Rest, if you are having your own data, you can actually give your own data as well, not an issue. After giving the similarly, so I have given the data for the office, which is having the population unit, this type of employee. You want to give the capita or capita 10 square, or if you are going for the hotel per customer, I have taken the hotel as an area near my network. So obviously the population is based on the guest. So what will be the unit load? Just a standard area is to be set where here, as I have integrated from the inbuilt libraries. After creating the thing within the SewerGEM, do remember one thing: creating anything within the SewerGEM is incomplete until we don't assign it. So do remember, once we create anything within the SewerGEM, we have to assign it actually. So under the loading, you can see we have the sanitary load control center. Once you go, once you give the input for the sanitary load, here you can see the column for the unit sanitary load has been offered. You can give the value, like I have selected the or office and hotel per customer. You can actually give that, and you can just simply assign it, not an issue. After assigning that, do remember to give the value for the loading unit count, because that is basically for the per person. So how much loading unit count would be there at, that is also required within the SewerGEM. So that also has to be given within the SewerGEM. After, the mandatory thing is giving the loading. So this is how you actually give the loading for a particular manhole. So we have here the unit dry weather load. Now, if we are going to analyze our network, let's suppose we are going to see the network for the average day demand. We are not going to go for the peak day. So let's suppose here we have the extreme flow, and we go for the extreme flow setup. So let's suppose the first thing come for the average day. So here under the extreme flow setup, we have the option. So from here, the first thing we can go for the average day setup, like what are the result once we go for the average day scenario or average day flow scenario. We can just add that as well. And after doing that, and once we go for the can validate our network, if there would be a issue within your network, it will show the error. And if there would be a if there is no issue within your network, it will show the method like no validation issue is found within your network. So now it means that you are good to go and you can compute your result. So let's suppose I'll just go and compute my result. So here you can see my result has been computed. easily. And now if we want to see the report, like suppose I want to see the report in the case of pipe, so we can see how much flow is there for particular conduit 13, and how much velocity is there. So like, and also the it is also generated automatically the D by D ratio. Now this is for the average day setup. And also you want to see the result in the form of color coding, we can actually give the color coding as well. So here, as you can see, within the conduit element symbology option, we can actually create the annotation, or we can create the color coding as well for the particular hydraulic element. If you want to, let's suppose I want to create the annotation for particular conduit in case of flow. So here you can see each conduit representing the flow, like how much flow is there within the particular conduit part. And if you want to see the result in the form of color coding, we can actually set the color coding as well on the basis of velocity, how much velocity is maximum or minimum. So we can actually see the result on the basis of color coding as well within the SewerGEM. Next thing, if you want to see the profile, because we have just seen for the average day setup, and now we want to see the some profile within this network. So we have the option for the profile as well. So under the profile, I have already created one profile. You can just go and create from the here new profile. If I showcase you, I'll just if I showcase you highlighting the profile. So I have created the profile from manual 6 to outfall 1. And if you want to see the profile, view profile. So here, this would be my profile, something like this. It will showcasing you, okay, my profile is working like that. And if you want to see the engineering profile, we can actually see the engineering profile as well. Here, this. You can see, okay, this is my manhole 6, this is my manhole 5, and outfall over here something, this is my hydraulic grade line, this is my pipe, and how it's flow indicating, and how much invert level is there, or rim how much is there. So this is how you can actually set the profile as well for the uh, whole your network. You want to generate your profile from manhole 13 to outfall, you can generate it. You can actually create the multiple profile. That shouldn't be a challenge. Now we have just see the scenario related to the average day. Now if we want to see and go for the peak flow scenario, for that also we have to follow the same step. So within the component we have the extreme flow. So once I go for the extreme flow setup, so once I go for the peak flow setup, here I have taken the peaking factor. You, if we wish, we can give own data as well. So under the extreme flows, so we have the different method for the peaking factor. Let's suppose we talk about the table population factor. If you are having the data in the format of table, we can generate that table as well within this. Or if we are having the like data in the format of load, we can actually generate that as well. So here are the some of the method. We can just go that method particular, and we can select the data. Rest the for the peaking factor, we are also having the inbuilt library over here. So you can actually import the library like peaking factor, US or SI. So there are some of the equation that are already inbuilt within the CVGEM. You can just do that as well within your network. Once doing that, and again, if you go for the extreme flow setup, you can just simply assign for the peak flow factor here. Before, for the average day, I haven't assigned anything because we are just going for the analysis for the average day setup. But now we are going for the peak flow setup. So we have going to assign for the peaking factor that we have just created. Okay. Now, so we have to just switch to the peak flow scenario. Once we go for the peak flow scenario and do the result. So in case of that, you can see before the velocity was near about 1.7, 1.70 something, and now it is generally the velocity got rises. So this is how you can actually, design your network or model your network for multiple creation. So with the help of scenario or alternative concept, the first scenario was for the average day scenario. Then I've created the child scenario, and I've switched to the peak flow scenario. So if I go for the average day, the value would change. If I go for the peak flow, the value would be changed. So this is how you can model your network within the SewerGEM simple model, and you can compute your model. Now let's talk about the automate design. So let's suppose if we wish to create the design the network within the SewerGEM, which would be automatically could be designed. So with the help of design constraint, we can actually do that. So let's suppose this is my network here. I'll just go and unhighlight the profile first. Now, under the analysis tab, we have the option for the design constraint. So once I go and click the design constraint, here you can see the dialog box for the design constraint is being appear. So on the basis of that, how much velocity we have to, if we wish, if we require to give the velocity minimum or maximum, we can give that value as well. If we wish to give the cover value, like how much cover would be there, how much cover would be there, like from soffit or from crown, or what is the type, like table or simple, we can do that and we can just give the value. Okay, my cover minimum would be this much feet and maximum would be lie between this much feet. Then we want to generate this slope. Let's suppose if I dis let's suppose I'll just switch to the base scenario, and if I see here we have slope 0.0059, 0.0054, or 0.0096. So under the design constraint, let's suppose we have to go for the slope and we want to give the slope 0.030 to between to 0.100. So we can actually design that area as well. So I'll just go and once I compute my result and I'll switch to the design slope to the 0.0030 and I'll compute my result. Now you can see my all the conduit now is having the slope value that we have just see within the design constraint. So there are the certain workflow that has to be followed while designing the Shiva network within the SewerGEM. Then let's suppose you want to design for maximum slope as well. Let's suppose now you are going to design your slope for the 0.0075. So we can just switch that scenario and just compute my result. So now you can see my all of the pipe having the slope 0.0075, and I have neglected the conduit 5 and conduit 6 to meet that design constraint area. So with the help of design constraint option within the SewerGEM, we can actually design the network automatically. So we have just to follow some of the criteria that has to be followed by the SewerGEM, then we can design it. And again, the same thing that I have done over here also. As you can see, I have created a different scenario. The first scenario was the base scenario. Then I want to design my network for the slope 0.003. So I have designed that network on the basis of that slope. And then I have again designed the network for the slope 0.0075. So this is how you can actually, design your network within the SewerGEM. So uh, this was this was all for the today webinar. I hope you guys had an knowledgeable session. So now we will just proceed with the Q&A session. So if you are having any question, please let us know. You can simply just put it in Q&A box so that it can be discussed over here only. Anyone having any questions? You can just put it in Q&A section box. Yeah. So for that, we have we have one question from Pranav Harit. Suppose I have 20-year rainfall data, so how can I put it in SewerGEM? So for that, we have the separate column within the SewerGEM. So today webinar was all about the Sewer networking. So I'll just showcase you like here. So here under the component, we have the storm data. Under the storm data, once we go for the storm data method, so here you can see the different method are present. Like you want to integrate your data time depth or time intensity or IDF table. You can just go for the one of the things. Generally, the requirement is for the time depth. You can actually go and generate, and once you go, you can actually give the value for the new return event. Over here, you can actually design a network, like suppose you have talked about the 20 year. You can give that 20 year, 30 year, or 40 year. That shouldn't be a challenge. So this is how you can actually, give your storm data. You must be having the data for the storm related thing. So with the help of storm data within the component, we can do that. Which method work best in my case? It totally depends like what data you are having. You are having the data in the format of time depth. You are having the data in the format of time intensity or IDF table. I hope you got your answer, Pranav. Anyone? Anyone having any questions? Please feel free to put it on the Q&A chat box. Uh, yes, I'll just talk to the my marketing team. So it will be uploaded on YouTube. So at there you can actually see this webinar. Satya Singh. Anil Pal. Hello, Anil Pal. Yeah. Any question from your side? Yes, sir, you can just write it on the Q&A box. Waiting for your query, Anil sir. Rest, anyone having any question, please feel free to put it in Q&A. How to distribute the population on each manhole? Like you want to assign the load for the each manhole, how we are going to assign the load that you are talking about? Am I correct? Yeah, I have just showcased that thing as well. So let's suppose if we talk about the loading here, if we talk about the C1 networking, so within the loading, once we talk about the C1 network, we go for the drive other load. So once you go and select for the sanitary drive other load, here you can set your method. So as you discuss how to distribute population on each manhole, so we can just go and select the population based method. On that basis, you must be having the data like how much unit load would be there and population unit. So these are the unit like it should be person per person type would be unit load or resident or student or employee or guest or capita. So this is how you can just generate the population unit and you have to give the unit loading data value. Once giving that data, what you can do is, let's suppose I'll give something 145 gallon per day. So under the loading again, we have the sanitary load control center. Once you go initialize, so from here you can see we have the option now for the third option as well for the population based method. You want, you can initialize the demand for all the element here. So in that case, you have to give the unit sanitary loading and also you have to give the unit, loading unit count. So this is how you can give the loading for the manholes. I hope you got your answer. Anyone having any questions? So we can just wind up it. So I guess we just go and wind up this session. I hope you guys had an insightful session, a knowledgeable session. So please be updated with us. So the next webinar would be on WaterGem for the water supply project. So do connected with us simultaneously. I'll do the webinar on WaterGem and SewerGEM. Is this a series of video of for explaining? No, no, it's not a series. For the series thing, actually, I have we have the on the YouTube we have the channel name then Capricorn. There you can find out the series related to the SewerGEM or WaterGEM. But you can say the all of the webinar that I am conducting is workflow based. So this is the base thing that the first thing is required within the SewerGEM that we have to do. There are something that we have to do initially, like catalog conduit or prototype we have to select. But everything is we could not discover within the webinar. So this was the base thing that could be followed within the workflow so that you can have a basic idea how SewerGEM could help for the Sewer networking and modeling. Anyone having any questions? So we will just wind up this session. So thank you so much for joining this webinar. I hope you guys had an insightful session. So please be updated with us. We are going to showcasing more webinar. So thank you everyone. Thank you. Have a good day.